Hey there, Diagnosing here. Today's video is about getting this little Mercury 110 up and running and is proudly sponsored by marineengine.com. The history of this motor is that it apparently was running, started having kind of steam and water spitting out the telltale and then wasn't running so well, and now I actually can't get it started at all. Because the primary sort of fault with this was a cooling system fault, I'm going to take the gearbox off and have a quick look at the impeller. With this particular outboard, I'm actually suspecting a bit of a head gasket problem rather than an impeller problem because of the description of the nature of the telltale. It sounded a lot like it was actually the combustion gases pushing that water out from the water jackets under force. It was really spurting, there's a bit of steam, etc. So that might also explain why it's not starting as well. If it was just an impeller problem, it would still start fine. I'm going to start by taking the leg off though, because it means I can check the impeller straight away and we'll know. And it also means I can start it here in the workshop, or at least attempt to start it without worrying about burning the impeller up because the gearbox is off. This one, the cowling comes off from the front here. There's a cable that goes to the back. I've never actually worked on one of these outboards before. So in some ways it's interesting because it sort of gives you an idea of how I might approach an unfamiliar outboard. I know in order to get the gearbox off, there's going to be some bolts holding it on and there's going to be some sort of shift linkage. The shift linkage is either going to be disconnected somewhere on the leg or somewhere up here under the carburettor area. So I'll just look in both those areas, see where it is, we'll go from there. The third option that I didn't mention is that sometimes you don't need to disconnect the linkage at all if it's actually just a spline. Instead of push-pull mechanism for the gear selector, it rotates. And this one, looking under the carburettor while I change gears, is a rotating style. That doesn't guarantee it's just a slotted spline, but there's a good chance of it. So what I'm actually going to do is just take the bolts off, drop the gearbox a little bit, see if it comes free. If it doesn't, we'll investigate further. On this outboard, looks like we've got a nut here going down. Here, just above the propeller, there's another nylock here, just after this little water intake grill. And there's also a section here that looks like it should have had a bolt in it. There's some thread there and there's nothing there, so there may actually be a fastener missing. So I'll take this one and the one around the top and we'll see what happens. I actually came this close to buying a set of imperial spanners this morning when I was up at the shops. Now I'm wishing I had. We'll find a metric equivalent. I probably spoke too soon about finding a metric equivalent. This is a very loose 15mm or a very tight 14mm, so not ideal. Alright, this isn't going so well. I'm going to go and pinch one of the arms, find out what it really is. Alright, looks like it's 9/16 of 2/2 of an inch or whatever it is. So that turns out it's actually 14.3mm, so makes sense we weren't having much luck with the conversion. Speaking of quirky measurements, like our 110 here, which is actually a 9.8 horsepower, I read the other day that a horse can put out a peak of 15 horsepower and that a person is actually about 1.2 horsepower. There you go. You can bore people at dinner parties with that. This nut's actually hit the top here, so it looks like we're going to have to drop the gearbox before we can get it off completely. So I'll move on to the one under here. I can't see anything else holding it on, so I'll give it a few light taps with a mallet. If it comes off, great. If it doesn't, we'll keep looking. Might give it a bit of a spray around this top thread. The thing I love about this sort of spray is it gives you 5-10 minutes just to space out while it sort of soaks in. Because it's the front edge of the gearbox that's not separating, I'm going to have a quick Google and see if I can find out how this shift linkage disconnects, because it may be the linkage itself holding it on, not just that this thread's stuck. So I don't want to be forcing it and then turn out they end up breaking the shift linkage. So I'll go see what I can find out. As I was suspecting, because it's a rotating type, it is just spline, but apparently there is one spline that's a bit different that helps sort of get it in the right orientation. And then sometimes people can sort of jam them together in the wrong orientation, but it makes them really stick. So we might have that problem, we might not. I'm actually suspecting just the threads here are stuck, so that oil's had a little while to soak in now. I'll just keep tapping it. Another thing I'm going to try is just winding this nut back down a little bit to open up a gap. And then I'm going to put a pry bar in and try and pry the end of the thread down. The nut's still there to protect the thread, so it should be fine. I guess I should clamp it onto this stand before I get too vigorous with it. I should also point out that this stand's actually just a normal trolley you buy at a hardware store with a plank of wood bolted onto it. So if you've got a small outboard and you're looking for a really quick and easy outboard stand, that's a really nice way to go. Seems to have done the trick. We've now got a gap all the way along, so I'll just keep tapping it down. The trick with tapping these things, use a rubber mallet. Don't break the ventilation cavitation plate. That's given us enough of a gap now to take this nut off entirely. I'll pop this on the lower unit stand now, we'll have a closer look. I can see now what I was just reading about with the splines here. I'll show you. You can see here on this side there's one section where the splines are missing, and that's what used to help align this with the other female spline coming down from the power head. Alright, we'll pop these two bolts off and check out the impeller. Looks like these bolts are 7/16. I'm going to clean this drive shaft up before I lift the impeller up just to make it easier. I'm just going to use a little bit of WD-40 and some 2000 grit sandpaper, so very fine. Won't scratch the drive shaft up. Looks like a little seal around the base of the drive shaft here. Alright, maybe it was just an impeller problem. It's clearly missing a couple of blades off the impeller. And this one here looks like it's snapped completely too. This is the little key that holds that impeller onto the shaft, so make sure you don't lose that. And that was the impeller, by the way. This gear selector shaft, the oil seal around the top of it, while we're here, looks like the whole thing could use a bit of a rebuild. So I'll order the bits I need to fix the seals and the impeller, and for now we'll try and get the motor started. The great thing about having this off is we can start it in the workshop, no water needed. Before we move on to looking at why this outboard won't start, I'll show you what I've already done with the recoil mechanism. I've actually replaced the cable because it was really short. I actually put my shoulder out. I don't know if I ever mentioned it, but I was actually first trying to start this motor, and it turned out the cable was about 1 foot long. And because I wasn't expecting it to be that short, I gave it quite a good reef and ended up putting my shoulder out because it stopped much more suddenly than I thought. So I guess a bit of a tip and something I learned is if you're starting an outboard that you're not familiar with for the very first time, maybe do one slow pull on it, make sure it actually does have the full length of cord and it doesn't bind up. Then you can start to do it with a bit of verve and vigour. But another cool thing I did learn, and the thing I like about this design, is you can actually add tension to the spring from the top here. So I'll show you that. Here on top you've got a little locking tab, so I'm just going to bend this tab down, which will allow us to loosen this nut. I'm going to bend it down using this hammerable flathead screwdriver. Looks like the nut on top of here is a 3/4 inch. So what I'm going to do is put the ring end on there and then hold this flathead screwdriver in the top of the shaft. Then I'm going to undo or loosen that nut a little bit. Now the main trick with this nut is that it's a reverse thread. So I've actually got to go clockwise in order to loosen it. Now if I turn the flathead screwdriver counterclockwise, I can actually put a bit more tension onto the spring. And then eventually, when I've got it where I want it, I can turn this locking nut counterclockwise until it's tight again. Once it's tight again, it won't uncoil. I've also rotated it until there's a flat section of the nut against a different tab than the one I just straightened, because it'll weaken as you straighten and bend it. So now I can use a fresh tab to lock it off. That particular technique works from it being completely slack, so you can put it all together with no tension in it and then just wind the tension on, lock it off. I actually find that much easier than like I did in the other video where I was pre-winding it using cable ties. That was a nightmare on the Yamaha one. So what else has happened with this motor so far is it's got new spark plugs and I've cleaned the carburettor. I've tested the spark, it has spark, so it's not like a kill switch or something like that not working. And if I spray a bit of Start Your Bastard into the actual carburettor, it still doesn't fire, not even once, does nothing. So going back to the basics of why a motor doesn't start, we know you need 3 things. You often hear it said that you need fuel, air and spark. So those 3 things are fundamentally what you need, but you can be a bit more specific. You can say, I actually need clean fuel. I've seen plenty of motors that won't start, get rid of this really old varnished fuel, runs fine. So we'll say clean fuel, and instead of just spark, we're going to say we need timing. We need spark that is firing at the correct time for this motor to go. With this particular outboard, I'm not really suspecting timing. Because I've been pull starting it over and over again and it's never done anything so much as even backfire once. Normally if the timing's out and you're pull starting a motor or cranking it over with the key, eventually there's just so much sort of fuel-laden air around that eventually that spark will ignite it either in the exhaust, in the cylinders, in the air intake, somewhere. And it's never done that once. So when they also say air, more specifically, you can also say compression. Having a cylinder full of air is one thing, having a cylinder full of appropriately compressed air is another thing. So all up, I would say you need clean fuel, a well-timed spark, and compression. Now, we know we've got fuel because I put spray in the carburettor, and that's a great way to sort of bypass the carburettor. You're just putting fuel in. But what we don't really know is whether that fuel is making its way into the cylinders. In a 4-stroke, that could be a problem with your intake valves, and in a 2-stroke, that could be a problem with the reed valves. I actually looked behind the carburettor and I couldn't see reed valves on this. I believe some of these 2-strokes also have rotary valves, so it may be a problem with that mechanism. It means that we're getting fuel into the crankcase, because I know I'm spraying it in there, but it's never being compressed properly, never making its way up into the cylinders. We can kind of test for that by seeing if the spark plugs are wet, and also by taking spark plugs out and seeing whether we ever see fuel or vapor coming out of the spark plug holes. In this case, I haven't, so I'm starting to suspect a fuel problem. I'm not really suspecting a carburettor problem because of the spray once again and because I've already cleaned the carburettor, but I am starting to suspect whatever valve mechanism this outboard uses to compress that fuel air mixture in the crankcase. What I'm going to do first though is just do a compression test. Let's just see if we do have decent compression. It's a nice simple thing, you can rule it out like that. Alright, to do that compression reading I'm going to need to pull start the motor. It's quite hard pull starting up on this rickety little stand, so I'm going to go put it back on the steel beam that I store outboards on and we'll do it there. We don't need any water of course because we've got the gearbox off. I'll just take these spark plugs out obviously, put the tester in, then I'll let you know the results. These are the spark plugs that came out of it, but I'm just going to confirm they're actually the right ones. As I was saying in the spark plug video, just because they were the ones in it doesn't mean they're the right ones. It's about 110, so not awesome, but not catastrophic. This one's 115, the other one was actually 112, so they're both the same, and ultimately that's what you're kind of looking for, is being within 10%, and they certainly are of each other, so maybe we can rule out bad compression. Alright, what I'm going to do now is jump onto the marineengine.com website and confirm that these are the right spark plugs for this motor, as I showed in that spark plug video, and then also have a look at the parts diagram and just have a look at what type of valves they use to seal off the crankcase. It's now early Friday morning and I'm going to push on with finding the reed valves on this outboard. From the parts diagram I can actually see it's up the top of the crankcase where the crankshaft comes through, so I'll start pulling the pull stud off and see if we can find them. I can't actually get my head around how they work in the position they're in, but obviously they do, so we'll see what we see as we go. 3 Phillips head screws hold this pull start mechanism on. Arn's outside trying to figure out why he can't get the electric windows on his Land Rover to go up. So if you hear lots of swearing, you know what that's about. To fully disconnect this, you either need to take the ignition coils off, or at least the wires, the trigger wires going to them. In this case, I'm just going to hang it to the side. Just putting a little bungee cord on it so that those wires aren't taking the weight. Alright, now I'll get an impact gun and see if we can get this flywheel off. Looks like this flywheel's 5/8. It's important to use a non-impact socket so that people have got something to criticise and comment about. There's a little washer in here that's hard to get out, so I'm just going to put a puller into these threaded holes and we'll pop it off. I'll give the crankshaft a bit of a spray first, can't hurt. I'll let it sit with a little bit of tension for a while rather than cranking it too hard. I'm going to tap this really lightly while it's got tension on it, see if we can kind of shock it free. You don't want to hit it hard though, because obviously it's a spinning component, so it needs to be balanced. I'm also not going to use any heat yet, because you don't want to melt the coils beneath it. Oh, we're in luck. Alright, there's the washer from the top of the flywheel. There's the woodruff key from the crankshaft. Everyone loves a bit of a goosey, so now I've got the flywheel off, I'll show you what's going on under here. So this is our stator, which is the still part of this sort of coil mechanism. You've got the flywheel spinning, which has the magnets, Then you've got these coils around here. Those two coils are providing some AC current. This one here is the trigger for the spark. So as this flywheel is rotating, as it passes a particular point, it sends a little signal to the CDI unit so it knows what position the crankshaft's in. So as the flywheel turns this way, as you accelerate, it moves this coil towards the rotation of the spark, so the spark happens earlier in the cycle. So that's how the timing advance happens. Quite a nice, simple sort of mechanical mechanism. Very common on outboards. Anyway, what we're going to do now is take this stator off by undoing all these screws. Okay, there's not a lot of weight in this. Now I'm just going to rest that stator up on here. This rotating section looks like it lifts off. This here is the spindle for the throttle. So you can see here this screw, where it's in and out, sets how far the timing is retarded on idle. Then this one here is a stop for how far the timing can get advanced. Down the back here, I'm not sure if you can see, but just down in there is a little roll pin that stops me pulling this off. I don't know if I'm going to get that out easily. I'll have a look. But what I need to do is sort of lift this whole unit off and just bring it to the side. It was just enough flex to get that over. A little bit dangerous, but I was lucky. In order to get that roll pin out, if you want to do it properly, looks like you might have to back the idle timing screw right out so you can rotate it enough to get at the pin. Now that's out of the way, we've got a couple of bolts here holding this top main seal on. And I believe this is also that reed valve body. So we'll take it off and see what we see. Looks like these ones are 3/8. Now I'm just going to get a pry bar, see if we can pry this up. This is metal, so I'm not too worried. So if I can find something else metal to pry against, I think we'll be in business. Under here is a main bearing. So there's a bearing here, and then there's a little roller bearing in here. Ah, I see. This is something that wasn't clear from the diagram because it was showing a single cylinder, but it turns out that this reed valve assembly is in between the two halves of the crankcase, which makes more sense now. I can sort of start to see how it works. It wasn't making that much sense when I was thinking it was near the top. What I can do though is see down into it, so maybe as we rotate the crankshaft we might be able to inspect all the reeds anyway. Just to the right of the conrod there you can see there's two reed valves there. So those two reed valves actually look in pretty good condition. If we can get the contrast right. And then there, if we rotate the crankshaft around, you can see there's two reed valves down the bottom half too, and they look alright too. So maybe they're in okay condition. Now this motor's probably not worth enough to start pulling it apart much further anyway, but they look okay. You know, if we sort of had an obvious problem, you go, look, this is what it needs, is it worth it? You can have that conversation. I did speak to the owner who said it's always been a hard to start motor, so maybe it is just one of those. Bit of low compression, maybe not a perfect seal, it's showing its age, it's not easy to start, but maybe if we can get it running, get a bit of heat into it, it might still have some life left in it. So I'll put it all back together and we'll have a go at starting it. I'll look up some fuel now. I've got this 2-stroke fuel tank that I use that's got every kind of brand of outboard on the end of it, so we'll pop the right one on, prime it up, see how we go. The great thing about all these outboard fittings that you're not using is they lock off when they're disconnected, so you can prime it without any leaks. I'm going to start by giving it a spray, see what happens. That's pretty funny. That's the first time that's even spluttered and it just ran. I'm going on a motorcycle trip this afternoon, so I'm going to call that a win and just run. Well, I hope you enjoyed this little tour of the Mercury 110 9.8 horsepower. I don't know what the 110 means. As far as I can tell, there's actually nothing wrong with it. The owner did say it was hard to start, but I kid you not, that's been pull start about 100 times without even a backfire, and that time it ran and idled, so who knows. Maybe it just wanted some attention. All right, well, take care then, and I'll see you next week. Bye.